Our next speaker doesn't really need an introduction. He's been with Pumps and Pipes forever. He's one of the founders, a esteemed colleague, an innovator, and a longtime friend, Steve Iger.
Thank you, Nicole, and thanks everybody for sticking around this afternoon, because I think that following my brief talk, we'll bring the students out with their cars, and I think you're going to really enjoy what they've done. They've worked hard all day today back in the pit area, getting their cars ready. Full steam ahead. This is kind of the talk that I was, title that I was given. Here's what I really wanted to talk about, which is basically planes, trains, and chemical clock cars. My life has been a pumps and pipes story, and we'll talk about that. When I talked to Nicole, or actually when she approached me about giving this talk today, she said, well, let's talk about mentors and let's talk about collaborations and how that's important. And then I also wanted to talk a little bit about students that I've met along the way. So here's my logo bio. The areas that are circled in red is kind of what I'm going to focus on today. But if you look at that, you can kind of see that my life has been pumps and pipes. So I grew up in Iowa, small town, 5,000 people. And here I am as a young man, and in fact, I was blessed with mentors all my life. And this has been a theme for me over and over and over again. So here I am trying to build a soapbox racer with the neighborhood boys. And in fact, my dreams were kind of like this, but probably the reality was more like that. But it taught me a lot growing up. And as far as my early mentors, I really have to say it was my mother and father that really tolerated a lot. But now I want to talk about kind of as things progressed. When I looked at this the other night, and of course I've never seen it on a screen this big, but did my mother actually match my socks with my shorts? I thought maybe she did. But what I wanted to tell you about is a heart valve story that started 12 years after this picture. Now, there's a lot to unpack in this picture, but I'm going to tell you a story that goes along with this. Small town in Iowa, friend of the family, she was diagnosed as having severe calcific mitral stenosis. She was young, in her 40s probably at that time, and she was sick and she was dying. I would guarantee if she couldn't walk across this stage without having to stop and rest and catch her breath. She really was dying. So at this time she came to Houston, and Dr. DeBakey here replaced her heart valve with one of these. It's a tiny ball inside a cage, and when she came home from the hospital, I was impressed. She was cured. She was healthy. Well, what you could do is you could put your hand on her back and kind of stand close to her, and you could sense this valve opening and closing. So you got to remember how old I was at this time, maybe 13, 14 years old. And obviously it struck me. It said, I really want to learn more about this. And so you got to remember back then there was no internet, there was no Google, there was no nothing. Basically you had Time magazines and Life magazines and anywhere you could go to try to find some information. So I dug up the name of 4 heart surgeons in the world. Of course, I knew about Dr. DeBakey because he replaced her valve. So I wrote these people letters and I said, please send me more information. I want to learn more about this. 2 of them never wrote me back. One of them wrote me kind of a nice letter, good luck. The team with Dr. DeBakey actually sent me a massive envelope of information. And it had probably 24 articles that were written. And so this kind of is the theme back to art, because one of the things that I saw in that article, or in those articles, was how richly illustrated they were. medical art. And that's when I really dug into this more and more. I wrote a paper. Another mentor of mine were two teachers in high school. Actually, unbeknownst to me, one of them sent what I'd written back to Dr. DeBakey. Shortly thereafter, I get a letter. And so I was invited as a high school student between my sophomore and junior year in high school, and then my junior and senior year in high school. I came to Houston from Iowa. God bless my parents for letting me do that. And worked in the surgical research labs at Baylor. I don't know, Billy, I didn't watch all of Billy's talk today, but did he talk about Dr. Liotta? Okay. So my job as a high school student really was to just be the gopher. I did this, I did that. But one of the things that I really enjoyed was Dr. Liotta would build pumps by hand. He would sculpt out the design, and then he would build them. And he taught me how to do it over the course of the first summer and then into the second summer. And of course, I was also struck during the second summer of how things had changed. All of a sudden, the group from Rice University became involved, and instead of kind of crude handmade pumps, these really started to look like kind of the blood pumps we see today. And so this was one of the earlier cases that occurred back in 1966, and actually, I'm not sure if it was this case, it was another one, but I was actually in the domes. They called over, this is once again when I was a high school student in the lab, they called over and they said, Dr. DeBakey is doing one of these, do you want to come? So I was up in the dome watching this, and once again, it just really kind of struck me of everything that we'd been doing in the lab was now being translated into what was being done in humans, just like with these valves. So, long story short, I did go on and enter some of this stuff that I did into a science fair. I don't know how good this shows up. I mean, my mother kept this article for years and years, and I finally dug it out, and it was all yellow and so forth, and so I tried to reconstruct some of this. But I did. I had this science fair project, and it really was a lot of fun to do. And so once again, we're talking high school pumps and pipes. I mean, it's been in my blood forever. Now, it's kind of interesting. I don't know if I can do this. So once again, with my parents, I kind of bought this they bought this little controller and these solenoid valves. And I took the compressor from the high school lab, and that was the power source. And so this is sort of a mock circulation with the pump, and it was a lot of fun. And then specifically going on to the International Science Fair. And I never thought I would win anything there. And at the end of the day, I ended up winning the AMA award. So it was really one thing after another during those early years of high school. Coming to Houston from Iowa in the lab, culminating in this. And then kind of the interesting part of this, 1967 was the summer of love in San Francisco. So once again, high school student, exposed to some of these things. It was a crazy time. So let's transition forward. A few years passed, here and there and everywhere. But a few years later, after the science fair, I was back in Houston. And I was working in the surgical research labs at Texas Heart Institute. And then also, over time, I became the clinical coordinator of what was called the Circulatory Support Service. And so I spent half of my time in the research lab, half of my time in the OR and the ICU. I'm not going to go through all this, but what I did want to point out was a couple of things. Medical art. Want to learn how to do a heart transplant? Well, there it is. There's piggyback heart. Testing a heart, a vascular graft over here. We did work on some early blood pumps with centrifugal pumps. This was way before some of the things that Billy was talking about, but we did make some inroads. On the clinical side, it was even more challenging. Billy's right. The pumps that we had in the beginning were huge, very difficult to implant. This is the second artificial heart that was ever implanted, me with a Jarvik pump. Once again, medical art kind of was exposed throughout, and probably the the best thing that we did back then, besides the pumps, the early pumps, was bedside hemodynamic monitoring. That really was a game changer for what we were doing. So, once again, my mentors at Texas Heart Institute were Dr. Cooley. This is Dr. John Norman. He's the one that actually recruited me and brought me to Houston. A spark occurred, an idea. And it was really a syringe of nitroglycerin. Dr. Cooley used to keep a syringe of nitroglycerin on the back table, and sometimes when he was operating on the coronaries, maybe they would spasm or one thing, and the anesthesiologist would see some EKG changes, and he would just take this syringe of nitroglycerin and just squirt it on the heart. And that was kind of a light bulb moment for me of, well, because everything before then was being delivered through the bloodstream, either intravenously or intra-arterially or inside the coronary. And so I kind of thought, well, what if we put the drug on the outside of the heart? So this is another mentor of mine from that time, Dr. James Woolerson. He was at Texas Heart Institute. He was the head of kind of cardiology at that time. He was also for years and years the editor of Circulation. So we kind of got to see all the cutting edge stuff that came in the door. But we designed some experiments and actually proved that this would work. Well, once again, I don't know if I can backtrack. That article was from 1996, so way back. Lesson learned. Sometimes, you're ahead of your time. But this is recent. This has been the last couple of years. The bottom article was published a couple of months ago. The pericardial space is now being looked at more and more as a source and a site of being able to deliver a therapeutic, whether it's cells or drugs or gene therapy. Medical art again. This was just published last month. Also now looking at the pericardial fluid that's around the heart. It may also be a source of cytokines and other bad actors that may actually influence the fibrotic process of the heart. So the pericardial space is being looked at more and more all the time, and that's kind of rewarding for me starting back in the 90s to see things kind of come forward where they are today. And in fact, that's kind of what my company does. That's the only thing I'm going to say about that, except once again, look at the art. You kind of maybe can appreciate that if you can give the drug in that site, there's a lot of targets that you can address. So enough of that. Let's move forward with pumps and pipes and why we're here today. It was great seeing Rob Ambrose today. Rob had been, a speaker at many of our conferences in the past. This is in 2012. Pumps and Pipes 6. By the way, this is Pumps and Pipes 18 today. He gave a talk about space cowboys. And when he was giving his introduction to his talk, he said, let's go rope some rock. But the other thing I wanted to point out, lesson learned, you always put the best looking guy and the smartest guy in the room in front of the TV cameras. This is the year that we brought the Lunar rover in and parked it on the driveway of the Methodist Hospital Research Institute. That's an interesting story. A couple of years later, Rob is back. This time he brought a robot with him. And this was kind of an interesting conference with Robonaut. Put Robonaut through its paces in our facility there. Had a lot of fun with it. David Alexander's here today. And this was one of the first live lunch and learns that we did from the TV studio that had been constructed at Houston Methodist. In the middle is Justin Fuentes. He, at that time, was head of Houston Independent School District stem cell program. We worked closely with him. But what was kind of fun about this is instead of just having somebody from the Jet Propulsion Lab kind of beam in by a Zoom or something, we actually went right into the sandbox where they had the Mars lander and all the different accessory parts of that. And so it was really a great program. And, talk about medical illustrations and so forth, and animations, NASA is a master at it. Billy. Of course, Billy has been involved with our Pumps and Pipes program since the very, very beginning. This was also back in 2012. This is one of the first live cases we did. We used to do live cases from the operating room. This was in the kind of the cath lab, the electrophysiology lab. Dr. Valderbano is an electrophysiologist, and he did a live case where he used Billy's devices to ligate the left atrial appendage, which kind of that little upper chamber of the heart, ligate that off in patients that have atrial fibrillation to prevent a stroke. So cowboy boots, because Billy always wore cowboy boots. Was he wearing cowboy boots today? Yeah, always in cowboy boots. Lariat was the name of the device, so kind of an appropriate name for the talk. The interesting thing is the Lariat device was an intrapericardial device. We've gone full circle. So let's move forward. Today we want to talk a little bit about chemical clock cars. And the car on the right, the Ferrari, was a car that we used over and over and over again, many, many times. Today, we have two new cars, and those are kind of the Fords. And you're going to see it here in a few minutes. Students have been working diligently for the last few hours to time these cars out. We've laid the course out for them. It was a 12-meter course, and it's gone end to end up here. So, May of this year, we traveled out to Seven Lakes High School in Katy. And at that time, we had 6 teams, 4 per team, that kind of were competing. Once again, they used the same little car, that Ferrari. And here they are, kind of mixing their chemicals and going through the process of, calibrating their car. So hopefully this video is going to run in a second, but what you're going to see is a couple of things here. First of all, over here on this side, this student is going to pour the peroxide into this container which has the iodine. The student over here is going to throw a switch as soon as that's done. Now, when that happens, here we go. And start the car. So in a few minutes, I'm going to talk about the guy that actually built this. But I kind of want to go through this process, and that's the 10-foot mark. Now, what you'll see is slowly this is going to start changing color. 20 feet. This is a 40-foot course at this time. And sometimes we had to nudge it over just a little bit if it was steering a little bit off center. And now at 30 feet, you're really going to start seeing the color change. A little bit more, a little bit more. And with the photocell, when it gets dark enough, there's 40 feet, it stops. So these students really did pretty darn good. They stopped within the finish line of the length of the car. We're really pretty pleased with that. Now today, we've got some challenges, because when we calibrated the cars, we were in a dark room. When we're bringing the cars out here, we're in a light room. So we're going to see how this goes. But that'll be the fun part of it, right? So one day later, loaded up the car again, and we went to the other side of town, to Atascocita, to the iSchool High, and we had not quite as many students that day, but we had 3 teams. And what I loved about it, and Nicole and her daughter really were the ones that kind of drove this. They actually made T-shirts, and all the students today had their T-shirts on. Once again, pictures of kids mixing up the chemicals. Now, it was important to realize, when Bill and I show up in the morning, they had no idea what we were doing. We bring this box of stuff. And so in a period of a couple of hours, we went through the whole process with them. They went through the calibration. And here we are again, on the start line. Same deal. Pour the peroxide in, get ready to turn the car on. Here we go. So the designer and the builder of this car, his name is Tom Lindsay. He worked at ExxonMobil with Bill. And I had the pleasure of working with 10 feet. I had the pleasure of working with Tom on many different projects, including a heartbeat simulator, 20 feet, and we imaged a model of a pipeline coming up on 30 feet. Now I think you're going to start seeing the color change. Definitely. How close are they going to get? Oh, I'm sorry, this was actually their first run. So they're pretty darn close. They finished within, what, a couple of inches of the finish line? So they did a pretty good job of calculating everything out. So a few minutes later, we kind of challenged them. They said, do you think you could do better than that? And they, of course, they said yes. So back they went, they remixed their chemicals, they thought about it, and a few minutes later, oh, wait a minute, that's not right. That's not it. Okay, here we are. So, same thing. And it goes, start the car. Are they going to do better this time? Now, once again, when they do this today, I hope that all of you that are still here today just come right down here and cheer them on and watch the cars, because it gets kind of exciting when you get down here. Well, okay, 20 feet. This is 30 feet. You're going to start seeing some color. Oh, I'm sorry, that was 20 feet coming up on 30 feet. So you're going to start seeing the color change. Now, over here on this side, up here is where that first little mark was. That's their first run. And wait for it. You can't get much closer than that. So can they do that today? We'll see. So here they are. They're really proud of it. We have a different team today, except for one of the team members is still here. The other team members from Seven Lakes are all new today. So this was run number 1, run number 2, and this is a challenge of whether they're going to be able to come down this course today and finish down there at the finish line. So this is really what they had to do. They had to create these kind of function curves on the amount of peroxide versus the runtime of the car. Now, as you can see, both schools came out with basically identical curves and lines. And the reason is they should have, because they were using the same car. Today, you've got 2 different cars that are running in completely 2 different ways. So let's see how they do. So here are the 4 members from the 4 students from each of the schools that are here with us today. Favorite line of mine from Bob Dylan: build a ladder to the stars, climb every rung. And then, of course, I've loved this quote by Carl Sagan: it's, we're all stardust, which is, I think, true. So let's go racing.